So in the last video, we talked about product of powers property. And this time we're going to be dividing and finding the quotient of powers property. So just a quick review, if I gave you something like, I don't know, 3 to the 4th times 3 to the 5th power, your job is to multiply these two things. And we keep the same base, but what we do is we add the exponents. We find out that 3 to the 4th times 3 to the 5th is equal to 3 to the 9. And this is if we're multiplying. So if we're dividing powers with the same base, what do you think we might do this time? And if you thought this, subtract exponents, you would be exactly right. All right, that's all we're going to do. So, for example, I have 3 to the 9th, and I am going to divide that by 3 to the 3rd. What is my common base? My common base is 3. What am I going to do with my exponents? I'm going to say 9 minus 3, so my answer is 3 to the 6th power. That's it. Well, if I do another one, say 113 to the 115th power, and I'm going to divide that by 113 to the 111th power, just because I'm making up numbers off the top of my head, what is the common base? The common base is 113. And I'm going to do what with these exponents since I am dividing? In this case, I subtract. So 115 minus 111, what does that give me? 113 for my base raised to the 4th power. Whew, that seems like a lot. So that's really all dividing powers is. It's just literally the opposite of a product. It's instead of adding the exponents, you're now subtracting. All right, so now let's do some things that got a lot of little multi-steps in it. So number 1 here, I have 3 to the 4th times 3 squared. All of this is being divided by 3 to the 3rd. Well, just like always, follow PEMDAS. I am going to add a little bit of extra in there, especially when we get into these weird things, because it's not just left or right here, but we also have an up and down. So I like to do it this way. I follow PEMDAS and I start with my when I have a weird fraction looking thing like this, I always do PEMDAS with my numerator first, and then I do PEMDAS with my denominator, especially when it's a really big one like this. And then I combine everything to get it to work. So let's do that. I'm going to start with my numerator up here. I'm not worried about my denominator right now, just my numerator. Follow PEMDAS. Up here in my numerator, do I have any parentheses? No. Do I have exponents? Yes, but I can't really do anything with them. Do I have multiplication and division? Yes, I do. I'm multiplying 3 to the 4th times 3 squared. Well, since I'm multiplying these exponents, what's that mean? I'm simply going to add my exponents right here. Since I'm multiplying a like base by another like base, my base is 3, and what's 4 times 4 plus 2? It's 6 over 3 to the 3rd. So I just simplified this. I said 3 to the 4th times 3 squared is 3 to the 6th power. All right, all over 3 to the 3rd. Well, now I have 3 to the 6th all over. What this is division, by the way. So what's this saying? 3 to the 6th divide by 3 to the 3rd. Well, this was really simple. I have a like base of 3, and since I'm dividing here, all I'm going to do is say 6 minus 3, and ultimately I get 3 to the 3rd power. And I could work this out farther, and we can ultimately get 3 times 3 times 3, which would be 27. Okay? So this one, I'm going to do the exact same thing. I'm going to work across the top, then I'm going to work across the bottom, and then I'm going to combine things. So let's work across the top, following PEMDAS. I have no parentheses. I have exponents, but there's nothing for me to do with those things. I have multiplication and division. So I have a to the 10th times a to the 7th. What I have is a to the 17th power. Okay? And this is going to be over a to the 6th times a to the 4th, because I'm done with the top. Now let's work with the denominator. Well, a to the 6th times a to the 4th, well, my common base is a, my exponents get added, and I get a to the 10th. Now I have a to the 17th all being divided by a to the 10th. And since I know that these both have a common base of a, I'm going to write that down. And since I know that there's division here, I'm going to subtract these exponents. And what's 17 minus 10? Well, 17 minus 10 is equal to a to the 7th power. Okay? Now, 3. This looks really, really complicated because I don't have common bases. I have an x base, a y base, a z base. And I have the same thing here. Looks really complicated, but let's follow through. I'm going to start with my numerator up here. Is there anything I can do with these terms? No. They are all different bases. X to the 4th, y to the 6th, z to the 3rd. There's nothing I can do with them. What about my denominator? No, they're all different bases. But here's the thing. I'm actually taking this number, this weird looking number, this is what it is, and dividing it by this. So guess what I can actually do? I can actually concentrate just on my x's now. I've done the horizontal way. I've looked at the numerator, couldn't do anything. I've looked at my denominator, couldn't do anything. But in this case, since I'm multiplying, hey, I know I can do a little something. I can actually concentrate just, and I'm going to do this with a really light pen. I can concentrate on this, and then I can concentrate on this, and then I can concentrate on this. Okay? And the reason why I can do this is because I've got multiplication here. All right? And I'll give you a little hint on something later on, just for further down the road. So if I look at it just like that, right there, I have x to the 4th being divided by x to the 2nd. What's my common base? My common base is x. I'm going to put this here. What am I going to do? I'm going to subtract my exponents. When I do, I get 2. So I'm done with that. Now, let's look at the next piece. I have y to the 6th divided by y to the 3rd. What's my common base? It's y. What am I going to do with my exponents? Well, since this is division here, I'm going to subtract. 6 minus 3 equals 3. Now let's do the nice one. I have z to the 3rd divided by z to the 1st. What's my common base? Z. What am I doing with my exponents? I am going to subtract. 3 minus 1 equals 2. Guess what? I have simplified this. I can't take it any farther. All right, so what you're going to do for me is I'm actually going to get you to do all 8 of these problems. I want you to try all 8. So it says simplify the expression, write your answer as a power. So you would do that. Simplify this, write it as a power. And this one right here, number 7, it says simplify the expression. I'm going to be more specific in this. I don't want it necessarily written as a power per se. I actually want you to give me the number, all right? So for instance, I'm just gonna make up something. You may end up getting 24x to the 3rd as an answer. I want you to simplify the expression and write it with a number, whereas in this one, you're just gonna write it as a power, such as, 16 to the 3rd, a 5th. That's your answer. All right, because it's telling me to write it as a power, so we would write everything as a power, where this one is telling me to simplify, so we simplify it to the most easiest way of reading it. So try 1 through 8 on your own. All right, for number 1, you should have just gotten 7, or you could put 7 to the 1 power. That would have been fine, but 7 would have been sufficient because since we're dividing, we do 6 minus 5, we would have gotten 1, and my common base is 7. All right, for number 2, my common base is negative 21, all in parentheses, and since I'm dividing 15 minus 9, when I will go ahead and work that out, gives me an exponent of 6, so negative 21 to the 6th power. For 3, my common base for all of this is 3.9 in parentheses, and since I'm since I'm dividing it, I'm going to go 20 minus 10. That would have given me a 10 for my exponent. My common base in number 4 was t, and since I'm doing 7, since this is dividing again, I'm going to go 7 minus 3 gives me 4. All right, number 5 gets a little bit more complicated. We're going to work out the top bit first. So 8 to the 7th power times 8 to the 4th power would have given you 8 to the 11th power over 8 to the 9th power. And now that we're just simply dividing now, we can subtract our exponents. My base would be 8 and my exponent would give me 2. All right, number 6, same concept. We're going to simplify the top by saying negative 1.1, which is my common base. And that's all being raised to, since this is a 13 and this is a 12, and they're being multiplied here, I'm adding this together and I'm getting 25. And that's all over negative 1.1 as my base to the 11th power. And now that I know that, since the base is negative 1.1 and my exponent's 25 and 11, and I'm dividing, that means I subtract these two numbers. 25 minus 11 gives me 14. All right, 7 may have stumped you just a little bit, but let's talk about it. I cannot do anything in the numerator because these do not match. There's nothing else I can do in the denominator. However, I can combine these terms right here because they have the same base. So I can rewrite this as saying k, and then I can say 3 to the 9th and 3 to the 5th. Well, what's this give me? That's k times 3 to the 4th power. Okay, now what's 3 to the 4th power? Happens to be 81. And what's k times 81? Well, you could rewrite it like this, and if you wrote this, that's absolutely fine, but this is the best answer. When we normally write expressions when it has a variable, we always write this number first when they're being multiplied. This is what we call the coefficient. So the better way of writing this is 81k. All right, so always have when you're multiplying a number in a letter, rewrite it that your coefficient is first. All right, 8 is another little bit of a confusing one. So let's work across the top. X to the 4th, Y to the 10th, and 2 to the 11th. There's nothing I can do here. All right, so let's look at around the bottom. Is there anything I can do with my denominator? No, because the base on this is Y, the base of this is 2, so there's nothing I can do. So let's check our vertical. Well, I have an X in the numerator. Do I have an X in the denominator? No, I don't. So I'm just going to write that down. There's nothing I can do there. All right, but I do have a y in my numerator and a y in my denominator. And since it's division, I can actually write this down as y 10 minus 8. All right, y to the 10 minus 8th power. And then I can look at my 2's. So this would be 2, and since I have 11 minus 7, well, we simplify this, and I get x to the 4th, y to the 2nd, and 2 to the 4th power. Well, what's 2 to the 4th power? It happens to be 16. Well, just like I said in the previous one, though this is the correct answer, this is the best way of saying it because we always write our number, our coefficient in the beginning of our expression. It's easier said that way. 16x to the 4th power y squared. All right, number 9, as always, I'm leaving this as your challenge question. I want you to think about it. It says the radius of a basketball is 3.6 times greater than the radius of a tennis ball. How many times greater is the volume of a basketball than the volume of a tennis ball? All right, so this one is definitely a tough one. And I really want you to ask me a question on this one, okay? Come talk to me about this problem because it's a really good problem and I'm giving it to you for a challenge. And that's it for this video, and I will see you next time. Bye-bye.